Hello guys, in this video I will explain you Spark architecture. So Spark architecture follows master slave architecture. So we will understand Spark architecture. Lectures for architecture, Spark architecture, and it follows master slave. It follows Spark follows master slave architecture. So in Spark we have one master node. We have a master node we call it as a Spark master. So in Spark architecture we have a Spark master is master node. Second, Spark worker node. Spark worker node. So we have two components in our architecture. One is Spark master and one is Spark worker node. Spark worker node or worker node. You can say anything. So Spark follows master slave architecture, and two main thing in the architecture there are two main components called Spark master and worker node. So let me draw the diagrams for this diagram. So we have we have a client here. We have a client. It will submit the job to our Spark master. This is the Spark master. We call it a master node. And here in the Spark master we have a driver. Or we call it Spark context. Spark context. Okay. Now when you're submitting, so this is our Spark driver. When you're submitting your job, it will come to the Spark context. It is the entry point to our Spark cluster. Okay, submit the job. Then what will happen? Then another component is there. It is called resource manager or EN. Resource manager, and we have worker node. We have multiple worker node. Worker node 1 executor. Sorry, we have executor here.
Battery low.
We have executor. This is another worker node. This is another worker node. And here we have application master.
Battery low.
AMS application master. There is another worker node 3 or 2. Okay, here we have a executor.
Battery low.
Executor this is your diagram. Okay, this is your diagram. So we have a client.
Battery low.
Let me So this is our Spark architecture. Now I'll explain what is happening inside. So I'll explain you the client submitting the job to the Spark context. Okay, it's what is the Spark driver of Spark context? I'll explain you. So it is the entry point to the Spark core or Spark cluster. So this Spark context or this driver will connect our Spark application with the execution environment in the cluster. So the entry point where that job will entry to our Spark environment. So, I mean Spark execution environment. Okay. Also, this driver, this Spark context will create a like graph, execution graph, and manage the partition and scheduling. Okay. So those things will do. You only one point you remember what is the Spark driver do or Spark it is a entry point. It creates a bridge between our client and our Spark execution environment. If you know the Java, there's one main method. Okay, you write a good Java main method. Okay, it is like a driver means you can act. It is like a main method which creates Spark context. So inside a driver, there will be Spark context. So driver will create that this Spark context. So this is a driver. The driver will create a Spark context, and Spark context will help you to connect your job, help you to help you to build connection between your job what you're submitting to the execution environment of Spark and to the Spark execution environment. Okay. Before Spark 2, we have a two different concepts called Spark session and Spark context. Now, now in advanced Spark version, like more than Spark point on Spark version, uh, Spark version 2.0.0 plus. So in this version, we have only Spark session. Before that, we have two concepts called Spark context and Spark session. Both is doing similar, doing same thing, but there is some minimal difference before this version. But in current version, there is nothing called Spark session or Spark context. There is only one thing, Spark session. Okay, there is no difference. Like before 2.00 version, Spark version, we have a Spark context also, we have a Spark session also. But now only Spark session. So what Spark session is doing? It is the entry point to the Spark core application. Okay, it will connect our Spark application with execution environment or cluster. So if we come to picture, the resource manager, okay, when we are submitting job, it will first come to the Spark context or driver. Driver will create a Spark context or Spark session. Then resource manager will analyze that job. Okay, what he is getting from what the resource manager is getting from client. It will try to analyze. It will try to understand how much try to analyze that job, and it will try to create an application master inside a container worker node. What is the worker node? Worker node is a container. Okay, container means some resources, some CPU with some memory. Okay, so container is a virtual entity which has CPU plus memory plus storage, CPU or memory. Okay, It is a virtual computer, you can say. So when some request came, resource manager will try to analyze the job and it will try to create one container. This is one container, okay, or you can say container with some memory, with some CPU. It will try to create a worker node, and within that worker node, it will try to create a application master. Okay. And what does application master do? After creating application master, application will request to resource manager for compute resources. Now application what will do, application will try to understand that job and try to analyze that, try to like analyze that job and come up with some request. Okay, what is that request? So application master will request that to execute this job we need some two worker node with some executor. So it will try to send back the request that we need two worker node with two worker node. It will say we need only 4 executor. Okay. So resource manager will try to, when application master is asking for some resources to compute this job, to compute this job, resource manager will provide those information, those resources to the application master. Application master will start those executor. If application master is saying that application master is saying we need 4 executor. Okay, so resource manager will provide those resources to the application master to complete this job. Now the application master will try to create this executor inside worker node. Okay, inside worker node. So what is the executor? If you can understand, container means your worker node means one container with some CPU and memory. What is the executor? Executor is a virtual entity. Executor also one virtual entity with some CPU, some memory. Inside worker node, we will try to create a pod. You can, if you know Kubernetes, we'll try to create one single pod, like one single virtual machine. You can understand with some CPU and some memory. So what actually executor will do? It will try to execute the task. The main thing of the main aim to create executor, that so that the executor can execute those tasks. Okay, so executor is actually executing our tasks. Now from here application master we have now after creating executor, application master just create executor and don't do anything. Resource manager will directly contact with this executor and schedule the our job. Okay, schedule our job. This remember, if we have a one job, then we have a one executor. See, if we have a job one, for that we have a one application master. So this application master job one. If we have another job two, we will create another application master AM for job two, like this. For every job we need a separate application master. Resource manager will create a application master for every job. So for request came to our driver, driver will get a Spark context, and then it will come to resource manager. Resource manager will try to analyze that job, and it will create, when it receive the request from Spark context, resource manager will create one application master. After creating application master, what does the application master do? It will try to try to try to come up with some request. Application will tell that to the resource manager that I need 4 executor to execute this task. Okay, so to execute this we need 4 executor. So when application master is giving that request, resource manager will provide those executor. See here you can four executor needed. So in worker node 1 we have a one, this executor 1 2, here we have a 1 2. Okay, now resource manager will directly schedule the job inside the executor. Okay, and executor have direct contact with our driver node. Okay. Now I'll tell you like I'll give you some theoretical perspective of everything. Okay, I'll repeat. So driver program is like a main method which will create a Spark context, and the first method will be created. So this is the first method. Okay, I'll write. Okay, what is this? How many drivers program will be there? Only one. Okay, we have a one driver program. Driver program. It will create Spark context. Spark context or fluctuation. Same thing in latest Spark architecture or session. Previously there is some difference. Now the same thing, because we in previous latest architecture we have only Spark session. We don't have a Spark context. But interviewer can ask what is the difference between Spark driver and Spark session. You have to read that. Very important question. And how many drivers? Only one driver. Okay. Every time we remember how many drivers driver program will be there. How many driver program will be there? Only one. What Spark context do? Spark context. When I say each the entry point to Spark core of Spark application. So it will connect. Spark context will connect our Spark application Spark job with the execution environment or cluster. So it will try to connect our Spark application with the executor execution environment or cluster. Okay. It creates job execution graph. I will explain what is job execution later. Okay. Also it is manage partitions, Spark context manage partition. I will explain those things later. Okay. Now resource manager. It will create what? It will create container. It will create container and start application master service in it. Application what application master do? Application master request to resource manager for complete resource allocation or to start the required executor. To start the required executor, we need to start the required executor, or how much resources we need to start our execution. So those requests will that thing will be requested by application master, and resource manager will allocate those resources. Okay. Also, one thing I will note here. Okay, we'll note it down. Very important. So executor will start interacting with driver program to send the updates of that job progress and the method program. Okay, one thing, very important thing. So executor will start interacting with driver to send updates for job process. mm, Others meta info. So executor will start interacting with driver to send the updates, okay, for job progress and others method info. Okay, so so this is a thing. Again, repeat this thing diagram. You can understand easily. So this thing, we have a client, we will submit the job, and when we are submitting job, on driver will create. Driver will create on Spark context. Spark context will then the job will come to research manager. Spark context is the entry point. It will try to connect our application to will try to connect our job to the research manager. After request got like after job received by a research manager will try to create application master, and application master will request for resources, and research manager will allocate the resources, and research manager will try to execute those tasks inside the executor. Okay, I hope you understand what I'm trying to say. So this is our Spark architecture. Okay, okay. You work on node on a container. Okay, you work on node a container where we have an executor. Okay, and the main interesting thing is I'll write one another diagram. Then it will be more clear to you what I'm trying to say. So we have a driver. Let me. For each job, we have a one driver. You can remember. Okay. So we have a got a job one. We got a job one driver. It's a like you can say Java main method. Like it is like this. Driver. Then we have a Spark context. We requested for another job. Driver. Let's see Spark context. So this is job two. And this is inside, everything will be inside Spark master. Spark master, we have a driver. Okay, for job one and job two. Now we have a RM, research manager. RM from here Spark context one, we are getting Spark context, we are getting job one, and we have a job two. Now what will happen? Research manager will try to create one container like worker node. We can say worker node. Worker node 2, I can say WN2, what is like worker node 2, WN2. It will try to get on worker node, and it will try to start application master. AM. This is for job 1. Starts by writing. Now another, now we are submitting another job. For that job we will create separate application master. So we'll create another job, another application master. We'll create another application master. AM. We get another application master for job 2. And main thing is this application master can be in different node. Okay, so if there is another worker node, let me draw another worker node here. Okay, worker node 1, worker node 3, WN3, WN2. So for first job we are creating our application master here and job 1. Now another job came. This manager will try to create a worker node. application master here. It depends on the resource manager. Not we don't have any control here in this case. Okay, but it will create, that is must. For every job there will be a separate application master. Same job 2 for job 2. That's why job 2. Okay, job 2. Now what will do? Now application master, this application master will try to allocate the try to send one request for resources. It will say that I need some resources to execute these jobs. So these requesters are so the allocated so these requesters are allocated by resource manager. So resource manager will allocate the resources. Okay, so it will try to allocate the resources here. Okay, now what will happen? See, if application master say we need we need two executors. So two executor, we have this two executor here, and here we can have a one executor. So executor and application master can be in same worker node. Okay, remember this is the executor, this is one executor. Okay, so as per the request from the application master, resource manager will try to allocate the resources. Now this resource manager will try to and maybe your question will be like which job, okay, who will decide which job will be in which node. Okay, so research for job one, research manager can pick any random worker node. Okay, there's no guarantee that uh, first job will be in worker node 1. Okay, for for any job, research manager will pick random worker node. Okay, that depend on the research manager. And what is actually inside this executor? This is our executor, no? See, inside this executor we have a, let's say, 5 tasks. We have a 5 tasks. You can say 5 tasks, 5 tasks, 5 tasks, 3 tasks. Okay, these are executor. This is our executor. Executor 1, executor 2, executor 3, executor 4. This thing, this is the executor. Okay, and maybe your so one question will be what is the task? What is the task? So you know that executor are actually holding some task. Okay, and executor try to executing this task. So actually executor is working to execute this task. What is task, you can ask? Okay, what is the 5 tasks? So 3 tasks. What is task? I'll come into later. Okay, I'll come in this topic up to 2 minutes. Okay, first I want to like I want to I want to convey one thing. So when you're writing code, okay, you will write some when you are when client submitting when client submit a job. So it will write so the client will write some code and it will try to submit that code .py file in python.py file using some command. Okay, so in that command, spark submit command, we have some parameters. You have to remember one thing: how resource manager will know that how many worker node we need. Okay, how many executor we need. So how many number of executor we need, how many number of CPU cores for the executor we need, how much memory actually executor will need, how such a resource manager will know. So main question is how resource manager will know that how many CPU core need by the task, by executor, how many storage is required, how many storage is need for this executor, and main thing is how many number of executor this job is required. How usage manager know? If you don't provide this option, usage manager can automatically figure out. Otherwise, you can mention also. So in Spark submit command, na? Spark submit command, we have options. So we can provide in Spark submit command. We can provide when you're writing code, when you're submitting your job to the Spark driver. You can mention this option in that Spark command. How many number of Spark executor you need. Second, number of CPU cores in each executor. That option is there also, you can mention in your command. Otherwise, system manager automatically figure out. But if you want to try to mention, you know how many, if you calculate manually and you know this much of required, you can put it in the command. Then third thing, and number of memory for each executor. So you have to submit three things. So when you are submitting any job in Spark command, you can mention these options, mention these numbers. Okay. Let's say I will give an example. We can mention we need 3 executor to execute job 1, 3 executor for job 1. Each executor with 5 CPU cores and 32 GB memory. Okay, so this is the thing. 3 executor for job 1, and each executor have 5 CPU cores and 32 GB memory. So this thing you can mention in Spark command, submit command. Now I will come to this question. What is task? We are like every time we are saying we want to executing task. What is the task? That you need to understand first. Okay. What is a task? Executor executing task. But what is the task? What is task? Okay. So if you can remember one thing, in MapReduce, in Hadoop, we have a block concept. Okay. So there will be B1 block in HDFS. So B1 block, B2 block. So in HDFS, we are storing data as a block. You know that. Hadoop will try to partition the data and try to divide the data and try to divide into block. Okay. So I think by default, if you have a 500 MB file in Hadoop, we need the block size is 128. So how many? We have a 3 or 4. Okay, 4 blocks will be there. I don't know. 4. We'll see 3. Let's think 400. 400, then we have a 4 block. Okay, you have a 4 block. If you have a 400 MB data and the block size is 128 and Hadoop, okay, then we have a 4 blocks. So if you have a 4 blocks, let's think we have a block b1 b2 3 blocks here. Map will try to map will we already we know we are every time say map reduce task. There are two type of tasks, only a map task, only reduce task. So mapper will try to read those tasks. Okay, so number of blocks equal to number of tasks. Okay, m1 m2 m3. So block 1 mapper will try to, and it will consider as a map task. Okay, map task. So number of equal to number of block equal to number of tasks. Mapper will try to read those blocks. So this thing you know already. Huh? So how MapReduce how MapReduce is working. So in HDFS we have a data. We have a data. Data will be stored in a block format, 400 data, and we will try to divide by 128 the default block size, and we will get 4 block or 3 block, 4 block I think. And if you have a 4 block, to MapReduce will try to from in MapReduce first map will start. Map will try to read those data, and that map will try to read the data, and we can say that that is a map task. Okay, so we have a 3. If you have a 3 block, MapReduce will try to get 3 map tasks. Okay, that is the thing, main point. This is the in the Hadoop and Hadoop scenario. In Spark, in this is the one. This is the MapReduce scenario. In that MapReduce scenario, now in the Spark scenario, what will happen? See, we have a HDFS. Okay, I already told you, Spark is not a replacement of Hadoop. Spark is a replacement of MapReduce. Okay, so you have a file.txt, and we already stored in this file.txt stored in HDFS. HDFS. So think we have a many blocks. Block 1, block 2. This data is so many, so big. Block 2, block 3, dot block 15, or block 13, you say block 13. So you have a 30 block in our HDFS for this file. Now Spark will come into picture. Spark will try to read 30 blocks data from the HDFS. So Spark will try to read all 30 blocks. 30 blocks. Okay, 30 blocks data from HDFS, and now it can create how many partition? Let's say 15 P3 P15. So one thing to remember, in Spark, number of blocks not equal to number of partition. Spark can partition data explicitly. So we have a 30 blocks on HDFS. Spark will read those 30 blocks, and it will try to partition data according to Spark. Okay, so there is no relation between block and partition. So if there is 30 blocks, it is not like that we have a 30 partition. No, Spark will create explicitly. Okay, so you have a 30 blocks, it can be 10 partition. It is depend on Spark. Okay, Spark can, one thing remember, Spark can partition data very important thing, we do explicitly. Number of blocks not equal to number of partition. Do remember, number of blocks not equal to number of partition in Spark. Okay, you can say block or partition is similar, but numbering will not match. If there is 30 block, it is not like that. There will be 30 partition. There can be 15 partition. There can be 10 partition. It depends, because Spark it can like create a partition explicitly. Okay. Now what will happen? Now what will happen? Now this tasks will come to executor. Okay, to execute those tasks, executor will execute this task. Okay, this partition. Okay, we have a partition now. Now job came to client. The client submitted the job, and in the job we are reading file from we are reading file, we are reading data from HDFS. Then we are data processing the data. Now when you're reading the data, what will happen? It will try to in Spark will try to create the partition, and to execute to process the data, it will try to send to our executor. So when this task is coming to our executor, na, then when is partition is coming to our executor, it is known as task. Okay. In one executor, this is the executor one executor. In executor, in a single executor, we can have many tasks. How many tasks will be there for a single executor? That depends on one. That depend on the CPU core. So this is the executor two. Remember. So we can have tasks two, tasks three, something like this. We have a executor can hold many tasks, but how many? Okay. So that will say I will now explain that thing. So if a if a executor have 5 CPU core, then if a executor have 5 CPU core, then that executor can have 5 tasks. I mean task means partition. When partition come into executor, it is known as a task. So if there is a 5 CPU core, if because I already told you when you are writing that command, na Spark submit command, we are saying that we need for this job one we need 3 executor, and for 3 executor for each executor we need 5 CPU core and 32 GB memory. So we are mentioning the CPU core. Okay, for each executor. So if we say for 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 if one executor have 5 CPU core, we have a 5 tasks. If one executor have a 3 CPU core, we have 3 tasks. Okay, 3 tasks means we have means that executor can have 3 tasks. So if that executor have a 14 CPU core, then that executor executor one has 14 CPU core. Then executor one can have 14 tasks. So the conclusion is number of tasks in a executor number of tasks in executor equal to number of what? Number of CPU core of that executor. That the rule. Okay. Why it is like this? Because each CPU core will execute one task. Remember why it is like this? So this is the important rule. You just remember thing, very important, very important. Number of tasks in executor equal to number of CPU core of that executor. Okay. Why it is like this? Because each task, so no, it means one task will be executed by one CPU core. one CPU core. Okay, this is a thing. Remember one thing: one task will execute a one CPU core. If there is a 5 CPU core, then that executor can only execute 5 CPU, 5 tasks. Okay, so that is the main thing here. I hope you will understand what I'm trying to say. Okay, this is a very important concept. How much so interview can ask like one executor can like how many tasks can a single executor can execute, which depend on the number of CPU core. Okay, that's it in this video. Bye.